Now we'll see the second type of isometric projection. In first problem, we saw how to solve when front view and one of the side view is given. If side view is given, that is either right hand side or left hand side. In this particular problem, which was asked in December 14 for 8 marks, front view and top view is given. So in front view and side view, we followed the method where we initially took the parts of equal heights, then we started drawing the three-dimensional view for those parts, and then going in increasing order of height from bottom to top, we completed the entire solution. In the same way, here there the common dimension for front view and side view was height, but here the common dimension for front view and top view is length. So we will divide the same views, front view and top views, into parts of equal lengths. Here you can see the parts of length 20, 25, 15 and 50 are given. So we will divide same the front view and top view into same parts. Now if the rule for dividing those parts, it should form a closed shape. Okay, if it is not forming a closed shape, then we will do the extra construction, and then after completing the view, completing the solution, we will see whether to keep that extra construction line or remove it. Again, starting with first making the box. For that I need to first calculate the entire length, width and height. Okay, the length here is 50 plus 15, 65 plus 25 will give me 90 plus 20, that is 110. Then height is directly given 60, and width here is again 20, 20, 20, that is 60. Okay, now again method is same for drawing the box. First draw horizontal line, mark the origin, then 30, 90 and 30, 3 angles. Okay, here the origin is given for front view here, so we have taken this front view plane, front view on a right plane. Okay, and obviously top view will be on this top plane. The procedure for drawing the box I have already explained in detail in first problem. You can just follow that procedure. Now we will start with the solution. So for that, first I will divide both the views into parts of equal lengths. So since it is, if I am considering the part from front view of 20 length, but it is not closed, so I will just draw extra line to make it close. Again in top view it is not closed, so I am marking extra line to make it close. Similarly, if you see the next height is next length is 25, it is again not closed, so I will make it close. Okay, so in front view, but in top view I am having one closed part corresponding to that 25, so no need to draw extra construction here. Then again for this 15 length I am having starting from here, again it is not closed, so I will close it here. Again for top view there is no need because I am already having a closed part for that 15 mm length. Okay, then remaining length 50, we have got this as 50, and corresponding part will be this. Okay, corresponding to this rectangle in front view I am having this closed rectangle of same length in top view. Now if you see, we are left with this rectangle, bigger rectangle starting from here to here, and corresponding length in the top view. So I am having two parts here as well as here, so we will go one by one. Okay, so first I am selecting this part of length 20 in front view, and then this part of again length 20 in top view. So obviously now the top view will be redrawn, these parts will be redrawn for top view on this top plane. In previous problem we draw those views, front view and side view, on left and right planes, but here top view is given, so we need to draw those parts for projecting on the top plane. Similarly for front view I will mark on this plane. Okay, now again starting with the origin, if I am starting from this point, we can start either from this point or this point. Okay, so if I'm starting away from the origin, okay, so if I'm taking this 20 mm, so first from the opposite boundary of the rectangle from the origin, I'll mark this rectangle of 20 by 60 in front view. So already 60 height is boundary, and so I'll take 20. I'll already mark the divisions. So starting with origin, we are having 50, 15, 25, 20. So I'll already mark those divisions for next lengths also. We are having 50 starting with origin, then 15 will be 65, then again 25 will be 90, and the remaining is 20 again. So first we are considering this rectangle which is having entire height 60 and then 20. Now corresponding to that, we are having this rectangle in top view, again starting from the boundary. Okay, so again I need to just draw. 20 is already marked on the top view plane also, so we will just produce this to this. So we have drawn this part on top view and this part on front, which is on right plane and top plane. Now as per our procedure, there for front view and side view, in first problem we projected corners from lengths along the widths and then corners from width along the lengths. Here now the common dimension is height. Okay, so we will produce now this corners from heights along the widths. Okay, and then this corner from width along the height. Okay, so we need to produce these corners. Obviously we are getting 4 corners here for that rectangle drawn in top, and again 4 corners for rectangle drawn, which are 2 common in that corner. In those corners we are having 2 common corners. So now I need to just produce. Already this line is nothing but the projector along the height. Again this line is along the rectangle boundary is projector along the height. So I need not produce projectors from these 2 corners, they are already drawn. So I just produce the projectors from remaining 2 corners from top. So from the rectangle in top view, I just produce projectors along the height. Okay. Again, from this rectangle, these corners I need to produce along the width. Okay. So from these 2 corners, 2 projectors are already projected. One is rectangle boundary and one is marked for marking the rectangle in top view. So again now I'll project from remaining 2. That is, one is this corner, another is this corner. Okay. Now since both the views are rectangle, so after completion the third will be a rectangular prism. So we can see I need to just join. Obviously for the observer looking from this direction, these lines, this line which is drawn from this corner and this line which is drawn from this corner will not be visible to the observer. Okay, as they are going behind this plane. Okay, we are having this plane in the front, so that will be visible to the observer. But after placing parts of remaining lengths, this plane may also not be visible, entirely visible. So we will see. But now I am sure that these lines are entirely visible. Okay. Again, in the top view, these two lines are visible. Some part may not be visible after drawing the next part. So I am getting this rectangular prism. So in that I'll erase these two lines because those are not visible to the observer. So after considering first part of common length, I am getting this rectangular prism. I will move to the next length. So in front view, that is along this plane, I need to draw now this part, which is again a rectangle of size 25, and height for that is, I need to calculate out of 60 up to this point is 20, so it will be 40. So I need to draw a rectangle of 25 by 40 starting from the topmost height. So I need to measure 25 from this point along this topmost line to 25, and I need to come down by 40, and we are continue measuring from this length because that part is common, that line is common for initially marked part and this part. So we are measuring from that vertical line only, but now I need to come down only by 40. Okay, so now I will complete that rectangle on an inclined plane. Okay, this rectangle is appearing on an inclined plane. Now corresponding to that, we have marked this part in top view, which is a closed shape again. So that for marking that plane part, now if you see, it is in the middle. So those parts, if you see the width in top view, it is equally divided into three parts, 20, 20, 20. So I'll first mark those division 20, 20. So it will be easier to mark the remaining parts of equal lengths. First I am marking that width of 20, where I need to mark this shaded portion. We are not drawing entire front view and entire top view and then projecting, because it will create a confusion, because many projectors will be there. So first, this is starting from this previously drawn rectangle. It will start from here and it will be for other 20 mm. I take this division. Okay, so from starting with this point, I need to measure 25 mm. So 25 here. So I draw a parallel line to this. So that will give me this shape. Now two parts of common length will be this rectangle, which is appearing in top, and this rectangle. Now again from the corners we need to project from top view along the height and from front view along the width. Okay, so I'll project the corners and then we'll see how to join intersecting. Now there, after projecting along the width and length in first problem, we first draw the top view, because front view and side view were already given. Here front view and top view are given. So after projecting these projectors, we will be first able to locate the side view, means view which is visible in this direction. So now we will see how to first mark the side view. So we have drawn the projectors from all the corners in top view for this particular rectangle. Now I will drop the projectors from this part in front view of equal length. So already from this corner it is already drawn. Again I'll mark from this corner, again from this corner and this corner. Okay, now we'll first see the projectors which will give me the side view first. So projectors from this and projector from this means I'm getting intersecting point here, here. Okay, right, then here and here. So this will give me this rectangle. There's some mismatching. If it is 25 measured, so this should pass through this line only. There is some error, minor error while taking the distances. Okay, so I'll get this rectangle as a side view. That means we are first marking the side view after projecting from top view and front view. Okay, now this was the previously drawn part, this rectangular prism, this and this. Now I need to decide from these corners where should I join with the previously drawn. Okay, now if you see, I am having one rectangle and other rectangle, so again I am going to get a rectangular prism, but for that rectangular prism the height is not entire 60 but only 40. So my rectangular prism will be only up to, so entire top view will be visible as a rectangle. Okay, and then height wise I need to go only up to 40. Okay, and it will again start with the adjacent to the previously drawn rectangle. Now this has complete the corresponding isometric for these two parts. Now we'll erase the extra projectors because it is giving me a rectangular prism which I already got. I'm first marking the side view because front view and top view projections will give me side view. So we'll draw, erase the extra projections previously marked. Sorry, this line was visible, it is not a projector. Now initially we drawn that entire line dark, but now due to this part placed in front, I'll be able to see only up to this line. Okay, not beyond that. Again, if any other part come below this, then this line may not be visible again. But for now, I know, and again for this height, it is visible up to this line. Okay, for the previously drawn rectangle. Now, next thing we'll move to the next length. That means this part. This one, again it is a closed one, so we got corresponding to this 15, we got one closed part in top view. So obviously I need to make, already for making this close we have drawn this line. Again for making here I'll just assume one more line, so I'll make that trapezium as a closed structure. Again for top view I'll redraw this small rectangle, so containing with this 20 mm strip I'll go further. Now I need to go by 15 mm. So along this line I'll go 15 mm to mark that small part. If your imagination is good, then no need to follow this method. You can select one part and directly start drawing the isometric projection, 3-dimensional view. But this method will help you by going step by step. So we have marked next top view, and corresponding to this top view we have this front view. Again, the front view rectangle initially drawn, this line was here, so this trapezium will again start with this line, okay, and then for marking this inclined line I should first mark the height. The total height from the bottom is 20 plus 10, which is 30, okay. So from this point I will go 15 mm on this side, then on this 15 mm line from the bottom I should take this point. I should measure this height, which is 30. So from bottom I will mark the point of 30 mm height, and then to draw this line I will join this point with this. So that means this inclined line now we are marking on the inclined plane, okay. So we will keep that line only, and then next part we have made closes this height. So I need to come down by 10 again. So 10, sorry, to here only, and then we will join with that rectangle, because if you produce that rectangle it is giving me the same length. So I will produce that rectangle to complete that, okay. So now we have got two parts. First one is this and second one is this trapezium, and now corresponding, to get the corresponding isometric view, we will project again. These two corners are already projected, okay. So I'll just produce projectors from these two remaining corners. Okay. Now we need to further produce this, because that height was 40, but we are again coming down 10 by 10 mm. So to initially drawn projectors we need to project further. Now for this, if I produce from this corner, now along the width we have already marked that point, that is the starting point of inclined line, but now I need to mark this point. So I will project from this corner, then again from this corner, and then again from this corner. Actually this is not needed because it is going behind, still we will mark it, okay. So now next thing is I need to decide, after marking we have started from here, okay, then I have marked this projector from this corner and this projector from this corner. So I will first mark the side view, okay. So on the same line I will get one more intersection, because this projector and this projector will coincide with this projector, and again for the same height, 10 mm height more below, from this projector again I am getting these two on the same. Now these two, okay. Now for joining this corner, which was the previously drawn part, this rectangular prism, now I should connect with newly drawn part. So for that I should get an inclined line in front view. So I need to draw parallel lines. If I draw a parallel line to this inclined line, so obviously it will join with this corner and this corner. Now again I need to repeat it twice, because that I need to draw for that width of 25 mm. So it will be like this. So this particular inclined rectangle will appear after drawing the projections in top view. It will appear as this small rectangle, but actually it is a true shape is inclined rectangle. Now if you see this line, now again I need to shift from here Now it is on the extreme boundary of the box, but now I need to shift inside. So I need to move to this corner, draw a vertical line of 10 mm, and again from this corner I'll draw a vertical line of 10 mm, and again for this corner I'll draw a parallel line to this. Okay. Now I need to decide for this line also, because this line, when I am seeing in front view, I should draw a parallel line to this line starting from this corner and again joining to initial. Now if you see, we have drawn this extra construction here, so that's why I am getting this vertical line. But if you see here, this entire plane is only a single plane, which was this rectangle initially, and then we have added this part. So obviously this was our assumption, and this middle line to make the closed structure of equal length. So now we can erase, because we know it is a single plane, not two different planes, because this line was imaginary for our convenience. Now we are done with these two parts, this trapezium and this small rectangle. No need to produce from this and make it dark, because it is going beyond. I am talking about this corner. No need to show the dark lines from here, because they are going behind. Again, if you see the previous rectangular prism, this side was visible and this side, but now due to this rectangular inclined plane, now it is going behind, so I will erase that also. Okay, so I will erase the top view rectangle now to avoid the confusion for next steps. These extra projectors, no need now. Again the projectors, this trapezium on front view plane. Okay. Now we have reached to this rectangular prism, outer larger one, entire height, then a small rectangular prism of height 40. Okay, then in addition to that we have got this trapezium, this inclined plane, and then again a small rectangle here. Okay, now we'll move to the next part, okay, which is the remaining length of 50. So we have done up to this, now we'll take this length 50, and corresponding closed part in front top view is this one. So for marking this, I know we have already reached up to these 2 points for previously drawn rectangle. Now I need to produce just the remaining rectangle up to the entire boundary. So I need to produce from here to here and here to here, so that is the length of 50. Okay, this is giving me the top view. Now corresponding front view is again a rectangle of 10 and height is length is 50, and that is located at a distance 20 mm above the base. So first I'll mark 20 mm above the base. So I'll mark 20 as well as 10, which is the height of the rectangle, and then I'll draw that rectangle here. That is small strip. It should be 1 mm below. Okay. So I have marked those two rectangles. Again, starting from the previously drawn this side. Okay. So we have marked this rectangle here and this rectangle in top view. Now again the same procedure, since we are getting both views are rectangle, so obviously we are going to get a rectangular prism. So for that the procedure is, I need to produce from each corner, from front view along the width, these corners, then no need to do for this corner because it is obviously going behind. So I'll just consider this one. Okay, it's not slightly matching actually. This part I think it's to this line, so we have marked some extra part because obviously the projector from this point corner should coincide with this line only, because we are considering the line, that this line which was considered for previous the trapezium is common for this rectangle also, so that projector should also coincide. That was the error in marking that length. Okay, so this is the rectangle. So now I will project along the width also, so which will give me the same line. Again, no need to project from this corner because it will be invisible to the observer. So we have finished with drawing the projector from front view along the width. Now we will start. Now the corners for top view are this 1, 2, 3, 4. So now I need to project along the height in these corners. So first I project, sorry, not these two corners, these two corners, because we have already covered this rectangle. So now the 4 corners in top view are this. So I'll first produce these corners along the heights. So this one and this one. So obviously projector from these corners are coinciding with this, because if you see here, this line is common for the previously drawn part in top view, and now this part is in continuation with this. So we'll get the same projectors, that means same lines for those projectors. Now we'll see what are the intersecting points to mark the side view. So if you see projectors from these 2 lines and these 2 lines and this one line, so I am getting these 4 intersecting points. So this small rectangle will be my side view for corresponding this rectangle and this rectangle in front view and top view. So I am getting this as a side view. Now my next step is to connect this side view with the previously drawn views. That means now we have reached up to this point. Now I need to see how should I connect this part with this part, okay, so that I'll get this rectangle in top view and this rectangle in front view. So it is simple. If you see the projectors, I'm getting this shape will be as it is because this line is common. So I'll just join this corners and this corner, these 2 corners, okay. And obviously, so for this line in front view, I'm getting this visible line, and obviously for this line I'll get this line, okay. Now if you see this line, I'm talking about this line now, it is starting from this square which we took 2 steps before. So this line will be a continuous line starting with that 40 mm height. So where that point was here, okay. So that line will be continuous up to this point, okay. There was some mismatching. So for these 2 corresponding rectangles, this smaller one and this bigger one in top view, I am getting now this rectangular prism. If you see this one, okay. Now in this part, if you see the previously drawn this rectangle, now it is going behind this rectangular prism, and it will not be visible to the observer either from front view or side view. So I'll erase those initially marked dark lines, okay, because I have finalized now this is the rectangular prism, but these lines are going inside which are not visible to the observer. So I just make that final view dark. Now because there is no part left beyond this length, I can make it dark because nothing will come alongside this, so that will be visible. Again, if you see, this line I am getting here because that was my extra construction to divide in equal number of equal parts of lengths, but actually that is a assumed line. And if you see, as we did for erase that line, this line, particular line in previous steps, because that was a continuous plane. Now if you see this plane, again it is a continuous. If you see this plane, it is continuous, so there will be no intersecting line here. So I'll get a continuous plane, so I'll erase that line. Okay, now if you see, I'll erase the remaining projectors to avoid the confusion. So I am getting this shape now, the entire shape. Now this line will be visible. This is the inclined rectangular plane, and so this line will be visible. We will make it dark in the final view. Now we are left with only one more part, which is we have done up to this, but remaining 20 mm height, we are left with this part. Okay, and corresponding to this 20, the length is up to 90. Okay, this much. And for the same length, common length, we are having this part as well as this part. And if you see, the top view is symmetric. That means whatever part we are going to get on this side will be symmetric to this side. Okay, so now we will correspondingly mark those views in top view and then in front view. So obviously in front view we are left with this rectangle of 20 mm height and entire 90 mm, because here it is 20 mm, so total width total length is 110. So I am talking about this rectangle now. Okay, so we are drawn on the right plane, that rectangle. Now corresponding top view, I am getting these two strips of 20 by 90 again. So those are nothing but this rectangle as well as this rectangle. Okay, now we will follow the same procedure again, dropping the projectors along the height, and then again from this point project like this point. Okay, 1 2 3 4 again for this point, but this there is no use of projecting this because it is going behind. Again there is no use of projecting this because it will go behind this already drawn part. Then for here I project downwards, and this is already projected. So I am talking about this rectangle, all four corners projected, this four rectangles already projected. Now I will project this rectangle along the width now. So one point, obviously this will coincide with this line, and at this height of 20, no need to produce projector from this because obviously it is going behind. I will produce this. Okay, now we will see corresponding to these intersections what I am getting. If you see for this part, I will be able to get this rectangle. Okay, and if you see this part, so this rectangle will be seen on both the sides, here as well as on this boundary. So this rectangular part I am getting on this rectangular face, right plane, as well as exactly mirror on the opposite side. So first this rectangle will be brought down by height of 40. Okay, means up to this point. So this will be seen here as it is. Okay, again I'll be able to see this intersection because here this plane is vertical and this plane is horizontal, so the intersection will be a line. Again, that rectangle in front of you will be visible. But now if you see about this line, for making the parts of equal length we have constructed this extra line, but now if you see this L shape is one plane only, so we need not show the separate intersections. Again, for the first part we took of 20 mm, we did this rectangular prism, there we draw this line also, but now due to this L plane which is in the front, these lines are also not visible. So along with this vertical line, this line is also not visible. Again, this line it was projected till this, because now this, due to this rectangle, this line will not be also visible. Now the same part will be seen on this side, but if you see, this point in the opposite side will be somewhere here, which is not visible due to these visible parts. So I will not be able to mark the corresponding parts, symmetric part on this side, means this corner. But if you see, I have to mark a parallel line, means this boundary, starting from the opposite corner, means this one. Okay, means that rectangle, this again parallel to this line, I'll get two lines like this and this I'm getting for this rectangle. So for this rectangle I'll get one more line from here, but it will go again behind this already drawn parts. Okay, so no need to draw that also. So just I'll be able to see this boundary, and that boundary not again up to the length, entire length of 90, but only up to this intersecting point, because it is visible to the observer only up to this point. But beyond this, due to this inclined plane, that line is not visible. Okay, so now we'll see how to complete the final view. Then again, here if you see inside view, this is a continuous plane. So here I'll be able to see the entire rectangle inside view. Because that height 20 plus 10, so 10 mm is above, so but 20 plus 10, those two planes, this rectangle and this rectangle are coplanar, so there is no need to show the intersecting line because it is a single plane, so we'll erase that. Now with this we know the final view, so I'll keep only those lines, so I'll erase the rectangle boundary which is not required now. So we have finished with final view. I'll just make that view dark, it will be more clear to you now. I'll erase the lines or projections which are not required. This question is actually simple, but same procedure you can follow for difficult problems also. Look once again in the solution and comparing with again front view and top view, because it will be a reverse problem for you again. That is, if this three-dimensional view is given and asked to draw the orthographic, then you will check whether you are going to get the same views, front view as well as top view. Again here, after drawing this rectangle, if you see, I am getting actually a T shape here. This extra construction we did for dividing into equal lengths. So now we can erase because it is the same plane, T shape, one plane only. We'll just draw a T plane again. So making them dark. Where two planes intersect, that means either horizontal or vertical, or horizontal or inclined, or vertical or inclined, I'll get an intersection as a edge. Like here, this inclined plane is intersecting the horizontal, so I'm getting an edge here. But if it is a coplanar, means two small planes are lying on the same plane, so I need not show the intersection by edge because it is a continuous plane. Like here, that in T. Again here, this line is not to be shown because it is a continuous plane. And this line, it is a boundary opposite to this. Again. You have to make the only visible part dark and rest of the thing, projectors and boundary of the box, you can erase. No need to show the dimensions again. So this completes the solution for this problem. So we have covered the second type also, where we divide the part into small, divide the entire view into small parts of having equal lengths. Okay, then projecting along the height and along the width, and first completing the side view and then connecting that side view to the previously drawn isometric view for each part.